Had a customer asking about creating vent cutouts, so routing slots into a part in order to create a vent condition. So created a virtual route subassembly that can be used to address a variety of different product types and can be used in a bunch of different ways. So working here in the spreadsheet because it's just a little easier to see, and I'm using the prompt values to drive some of this. So I've created a vent cutout here in the toe kick, on the left side, in the bottom panel, and then in the door. And so the way that these vent routes work, depending on the orientation, or position, you can use the width, height, and depth in order to control them. So in this case, where it's on the toe kick, position is in the back, meaning it's machining on the back of wherever this position is. And so here it's going to be 10 inches wide, meaning the grooves, because they're horizontal lines, are going to be 10 inches long. The height, so the distance between the top and bottom groove, is going to be 2 inches. And then the X origin, so this is measured from the bottom left corner, so just like your UCS would be. So the bottom left corner is going to be at 5 inches, and the Y origin from the back of the product is going to be 20 inches to get to the face of the toe kick, and then it's just going to be 1 inch above the 0. So that's for the toe kick. Then for the left side, the width is 0 because we're just going to put it into the left panel. So the height is in this case, horizontal lines is 0. So it's the length of the vertical lines. The depth is going to be the distance between the front and back of those routes. The X origin is going to be the inside of the panel so that we can machine on the inside with all the other machining. The Y origin is going to be 6 inches from the front of the cabinet. And the Z origin is going to be just a little bit above the toe kick there. Here on the bottom panel, the width, these are routing side to side. So the width is going to be the length of the grooves. The height is going to be 0 because it's in the XY plane, and the depth between the front and back groove is going to be 4 inches. The X origin, so the left front of the groove, is going to be here at 2 inches, and it's going to be in from the back panel by that amount, and it's going to be on the face of the bottom. It's going to be on the underside of the bottom panel, so it's positioned in the top. That way it can machine with the dado construction in this case. And then here on the door, the width is 4 inches, so these are vertical lines as well. So the 4 inches is going to be from the leftmost to the rightmost groove. The height is going to be that dimension, and the depth is actually not used in this case. It could be 0. And the X origin, 3 inches in from the hinges to end into the back of the door, can just be sitting up against the back of the door. And then the Z origin for where that's located. And so that creates a variety of grooves in here. So the grooves are broken down. We can have one or multiple grooves in length. So these are spaced out. They've got a dimension based on the length. It's just dividing it into sections. And so here, because these are virtual routes, there's nothing that you can click on to get to the subassembly property. So there's this little dot in the origin point for that. So if we go to our subassembly prompts, we can adjust all sorts of things about this particular set of vent routes. So these are going to be vertical lines. We can specify the height and the depth for this. We can specify the spacing. So most of these things are driven, in my case, from the prompt values, so I wouldn't modify them here. But we can adjust maybe the route minimum spacing. Maybe we want 1 inch minimum spacing in between those, and we could change this. So I just want 2 segments, and the gap in between them, maybe I want a little bit more space in there, so I can change the distance between the start and end of the 2 routes. I can specify the tool diameter. I'm specifying what the tool is. The tool diameter is just used in order to calculate spacing. So I could change the tool diameter from the default here if I wanted to, and just update that. And so with that, you can adjust, you can see, how that's updated. So yeah, you could use this subassembly to do all sorts of different grooves in different parts of the cabinet, and you could change what machining face it's on and things as well. So if we wanted to do that here in maybe a countertop, put some grooves in the back for over a radiator, same sort of thing, we can put this vent routes subassembly in here. And one of the nice ways to be able to use that might be to use the clipboard and add that to the clipboard so that you can paste it into other locations. Maybe give it a name of top, side, left, bottom, whatever, with the appropriate dimensions in here. But here I'm just measuring and placing that. I'm running the route side to side, and so we could change this and draw that out. And so here you can see I've got a variety of different routes in there, and again I can go into the subassembly prompts using this little indicator on there. Maybe I want to change my route minimum spacing. Maybe I want this to be 2 inches and maybe a little more space in between the parts in here, so I'll just make that 4 inches and adjust that. So you can see there's lots of different ways that we can use that subassembly to create different types of routes. In this case, obviously, I should have changed the route depth to route all the way through, but lots of different ways that we can use that. Same thing here, if I wanted to maybe do that on a mitered shelf, put the machining in here. Now, if I'm doing a mitered shelf, I'd want to make sure that I'm running on the correct face. I'd probably always want to make sure of that, but in this case, I want to make sure it's in the same face as the miter fold so that I don't end up machining on the wrong side. So here, if I put this in this position, so this is at Z0 with a position of top, which means it's actually going to machine from the bottom side. So that's probably not what I want, because if I draw this part in 2D, you can see here that my machining is on the wrong face, so it's going to machine on the back side of this part, which I wouldn't really want for a miter fold condition. So what I'd want to do in this case is change this to machine from the top, so into the bottom of this virtual route condition. And so this one here, so I'll use the material thickness as my Z origin and my position to be in the bottom. And I'll just change this to front to back for fun. So I can see, I could run front to back routes. Obviously that's an awful lot, so I could change that. Given that this is the virtual routes, I want to make sure that I click on the little dot in the corner there, and maybe change this route spacing to 4 inches or something. So there, you can see I've got my routing in there, and now when I do that routing, you can see that it's happening on the same face as my miter fold. So lots of different ways that you can use the vent route subassembly to create different routes and cutouts inside of any type of product.